Welcome to the electronicshobbyblog.com. Guess what? Our parts are in and we can continue building our resistor substitution box. But before that, I thought I'd share a couple of problems with you. You know, I ordered those knobs off Amazon and I was so excited when the package came. I tore it open, it was empty, completely empty. Amazon sent me a prime envelope that was empty. No tears, sealed all the way around. No way the knobs could have fallen out, so someone never put them in. So I called Amazon, they refunded my card, no questions asked, reordered the knobs. Problem number 2. I thought those knobs would fit those switches, looked like they would from the specs. My mistake probably, but they don't fit. So I looked at a couple of alternatives for fixing them. I took a couple of them and tried to drill them out. We're really only talking a couple of millimeters off, but it was just a little difficult to drill them out, and in doing so, I actually spun the the number skirt off of one. So it didn't work out too well. Was able to drill a couple of them out, and I'll save those for another project. So I went on Mouser last night, and I ordered a few more knobs. The bad part is they're a little more expensive than the ones I've had, but I'm sure they're better quality. So I ended up paying $6 a knob for them. So don't order the knobs I recommended in the first video. I'll let you know how these Mouser ones come out when they come in a few days. And if everything's okay, I'll go ahead and give you a part number. You can order them. Until then, let me show you something. Be right back. So this is where we're going to get to by the end of this first session. I've marked out the front panel. I've drilled it, I've test fit the switches and the binding posts. And so if you look at the back, you can see we will, in fact, have plenty of room to wire this up inside without worrying about shorts. And we've got plenty of room side to side and front and back that we don't have to worry about interfering with the case. So let's go find out how I did this. I started by applying blue painter's tape to the faceplate. I started by lining it up with the top of the flange. I didn't want to put it in the flange because I want to be able to slide the faceplate in and out of the box to test fit. And the tape would interfere with that. Applying the tape to the faceplate will not only allow me to draw on the faceplate and mark where the holes go, but it'll also help to protect the faceplate throughout the construction process. I won't have to worry about scratching that nice black aluminum finish. Once I'd applied the tape, I flipped it over and then used a hobby knife to trim it up. This blue tape will stay on the faceplate until we're completed and we're ready to install the switches. Actually, it'll come off right before that because we're going to want to apply any markings before the switches go in. But the tape will keep the faceplate nice and safe. After I applied the tape, I placed the controls on the faceplate, the switches and the binding posts, and kind of adjusted them to see how they would look in different locations. I wanted to make sure there was enough space in between each switch and between the switches and the binding posts and the switches and the edges of the case so that we wouldn't have any accidental shorts. I also wanted to make sure there was enough room to work with them. Once I was happy with the arrangement, I took some measurements and then started transferring those to the blue painter's tape. If you'd like to use the same layout that I used, here's the dimensions and the drilling holes. You can also find that drilling guide on the webpage at www.theelectronicshobbyblog.com and just look for the Resistor Substitution Box Part 3 post. I continued marking out the panel until I'd marked the intersection of all the controls. Once that was done, it was off to the drill press. I started by drilling some 1/8 inch pilot holes. Drilling the pilot holes would ensure that the drill bit stayed nice and centered as I moved up to larger drill bits. After drilling the 1/8 inch holes, I re-drilled all the holes using a 1/4 inch bit. Once I'd finished with the 1/4 inch bit, I moved to a 3/8 inch bit. And I drilled all the holes with the 3/8 inch bit. The 3/8 inch bit would actually end up being the final size for the binding posts, as they're designed to fit a 3/8 inch hole. You can see I'm drilling those here. After completing the 3/8 inch holes, I switched to a 5/8 inch drill bit and drilled the remaining 6 holes for the switch shafts using the 5/8 inch drill bit. When using a drill like this, it's important to keep safety in mind. I made sure I was wearing safety glasses. Another important safety tip is you never wear gloves when you're using a drill press. If the bit were to catch the fabric of the glove, it could pull your hand in and break it. To ensure the switches fit flush against the bottom of the panel, I cut off the little nub that's supposed to prevent them from turning. I didn't want to drill the extra hole. And without the nub, I'll also be able to arrange it so the top of the switch is exactly at the 12 o'clock position. After that, I installed the switches in the binding post for a test fit. Looks pretty good to me. Here you can see the front panel slipped into the box itself. Looking good. Well, that does it for this episode. Just because we don't have the knobs, though, doesn't mean we have to wait. We can start wiring up the resistors on the back of the switches and adding any additional wires so that we're all ready to connect everything together and close up the box. In fact, we don't have to put the knobs on until very last, so they're not going to stop us from continuing. So the next episode will be up in a couple of days, and you can see how we're going to wire up the switches and get everything tested. See you then.